Now example 5.16. Two masses 8 kg and 12 kg are connected at two ends of light inextensible string that goes over a frictionless pulley. Find the acceleration of the masses and the tension in the string when the masses are released. Now see, suppose as shown in the figure, we have two masses suspended at the free end of the string, which one is passing through the pulley. Here, arbitrarily, we considered this thing. Mass M2 is greater than mass M1. So, obviously, you can easily understand this thing. This mass M2 will move in downward direction and mass M1 will move in upward direction when these are released, okay, or we can say allowed to move. Suppose entire system is moving with acceleration a. So here now we can represent the forces. So first think about mass m2, so its weight that is in vertically downward direction m2g, and the tension in the string at the end of m2, that is suppose T1, okay. Then after, weight of mass M1 that is M1G is in downward direction, tension T1 that is in upward direction. Now suppose we prepare the equation of motion. So first think about the motion of mass M1. M1 moves in upward direction with acceleration A. So we can write the net force acting on mass M1, that is T1 minus M1G, and that is equal to M1A. Similarly, equation of motion for mass M2, M2 is moving in downward direction with acceleration A. So we can write the net force, that is M2G minus T1, the second equation, equal to M2A. Now, if we take the summation of these two equations, then T1, T1 cancelled. So we can write M2G minus M1G. From that, if we take G common, then M2 minus M1 into G. On right hand side, M2 plus M1 into A. Now, if we make A as a subject, then A equal to M2 minus M1 upon M2 plus M1. This whole thing into G. So now this one is the equation for the common acceleration of the system. Now, we have the equation T1 minus Mg equal to M1A. So here make T1 as a subject. So T1 equal to M1G plus M1A. Now substitute the value of acceleration, means this equation here in this one. So T1 equal to M1G plus M1 into M2 minus M1 upon M2 plus M1, whole thing into G. Therefore, T1 equal to M1G, and now take this M1 inside the bracket. So M1 M2 minus M1 square upon M2 plus M1 into G. Now take this M2 plus M1 LCM. Take G common from both the steps. So we can write M1 into M2 plus M1 into M1, so M1 square, plus M1 M2 and minus M1 square, so M1 square cancelled. Resultantly, we will get T1 equal to 2M1 M2 upon M2 plus M1 into G. So here this is the equation for tension and this is the equation for acceleration. Now to calculate tension and acceleration, substitute the values. First see acceleration, that is m2 minus m1 upon m2 plus m1 into g. Here we considered m2 is greater than m1. So see, we have to take m1 that is 8 kilogram, m2 that is 12 kilogram. So acceleration, that is 12 minus 8 upon 12 plus 8 into 10. You will get answer 2 meter per second square. Then to calculate tension T1, here substitute the value of mass m1 8, m2 12, then 12 plus 8, and you will get tension T1, that is equal to 96 Newton. Clear to all of you? You can use these equations of acceleration and tension directly to solve the problems related to pulley as shown in the figure. Okay.